Hey my dear data friends, it's Nicola from Data Mozart. In this video I'll show you how I managed to reduce my Power BI data model size by 90%. Yes, you heard me well, 90%. Stay tuned and you'll learn what are the best practices to keep your Power BI data model size in optimal condition. Here is our data model. We have fact chat table as a central table within the model. It stores data about the chat performed by our customer support department. If we check here in table view, you can see that this table has slightly over 9 million rows. So nothing special in terms of volume. I mean, Power BI should be able to cope with that without any problems. Few additional dimension tables, dim country and dim product, nothing special really. All tables were imported in Power BI as it is, without any additional optimization or transformation. So just simple checking the table names and import mode. To be able to follow what is going on with our data model, I will use DAX Studio. For those of you who are not aware, DAX Studio is a fantastic free tool created by Darren Gosbell, Marco Russo and Alberto Ferrari, and it has a whole bunch of very handy and useful features. In any case, if you're working with Power BI on a day-to-day basis, you should definitely start using DAX Studio. Believe me, it will make your life much easier and it will boost your productivity. That being said, one of my favorite features within DAX Studio is a VertiPack Analyzer tool that will help us to see the numbers behind our data model. So basically, VertiPack Analyzer tool just collects data from various dynamic management views. You can also use tools such as SQL Server Management Studio to query DMVs and get data about your data model, but you will probably find it in much more readable and understandable form within VertiPack Analyzer in DAX Studio. So I will click on the Advanced tab and open View Metrics. That will show me different numbers related to my data model. I can see all the tables for my data model, their cardinality, size, etc, etc. So just to be clear, all those numbers are in bytes. So you can see that my biggest table fact chat is approximately 2 GB in size, together with hierarchies of course. Now if I click on Summary tab, I can see that the total size of my data model is 1.86 GB. So that's our starting point, 8.6 GB, and I want you to remember this number. I will now go back to tables, and if I click on this small arrow next to table name, I can see all the details for the specific columns within the table. I can see their cardinality, column size, which is calculated as a sum of data size, dictionary size and hierarchy size. So basically this number is sum of those three. I can see which encoding type VertiPack applied to compress the data in this column, and I can see data type of this column. An extremely important metric is percentage of space in your table and in database that specific column occupies. So I can immediately spot that, for example, date team start and date team start UTC are the most expensive columns in my data model, both of them taking around half of gig each of them. Next, I have source ID and chat ID column. Chat ID is nothing else but the surrogate key from the data warehouse, and source ID is the source key from the underlying original data source. Both have cardinality of maximum cardinality of the table, as they contain unique values. What is even worse is that source ID is of text data type, so dictionary size is extremely huge for this column. So for the starters, I will get rid of this source ID column. In any case, I don't need two columns with unique values for any kind of calculation. So I will go to my Power BI desktop, go to transform data, and I will get rid of the source ID column. Let me just scroll to find it. Here it is, and I will remove this column. Let's now hit close and apply and wait a little bit for Power BI to apply these changes. Okay, that was fast. I will go back to DAX Studio and refresh my view. Here, if I go to summary, you can see that now data model size is 1.54 gigabytes. So just by removing one single column, we reduce the data model size by more than 300 megabytes. Again, I will go back here and let's go to our fact chat table and do some additional analysis about which column can be removed without impacting our data model and our calculations. As I said, do we really need both original start time of the chat and UTC time, both stored as date time and both going to a second level of precision? So I will get rid of original start column and keep only UTC values. Other than that, session referer and referer columns both have cardinality greater than 1 million and both very expensive because they are of text type. Also, I check with my report users if they need of these columns, or maybe only one of them, and I got the confirmation that they don't perform any kind of analysis of those columns. So why on earth should we bloat our data model with them? Another strong candidate for removal is the last edit date column. This column basically just shows the date and time when the record was last edited in the data warehouse. Again, check with my report users, they didn't even know that this column exists. And it also appeared that my users don't need chat variables column for analysis, as this is just a bunch of JSON records from the original database imported as it is. So in any scenario, they are not useful in this form for data analysis. So I will go back again to my Power BI desktop file, again to transform data, and let's get rid of those additional columns that are completely useless in our data model. So I will go to fact chat, and let's get rid of those columns. So date TM start, then also, as we said, referer and session referer, then additionally we said also last edit date and chat variables. I think that's it. So remove all those columns. So we have 6 columns removed from our data model. I will hit close and apply and wait for Power BI to apply those changes to my data model. So let's go again to DAX Studio and check if that brought some kind of savings to our data model. I will again click on view metrics and summary, 660 megabytes. So just remember that we started with 1.86 gigs and we shrinked 2/3 the size of our data model by just removing few unnecessary columns. So checking which columns are unnecessary and unused in your reports should always be your starting point when you're performing data model size optimization. Keep that in mind. True to be said, there are some other columns which could be dismissed from our data model, but let's now focus on other techniques for data model size optimization. As you may recall from one of the previous videos where I talked about VertiPack and the way it stores and compresses the data, I was emphasizing the order of importance of different parameters that affect the model size. And I mentioned that cardinality is number 1, so number of distinct values within the column. The rule of thumb is the higher the cardinality of your column, so the more distinct values in it, it's harder for VertiPack to optimally compress the data, especially if we are not working with integer values. There are multiple different techniques for reducing the column cardinality, and the most popular one is column splitting. I'll share with you now a few examples of using these techniques. Before I show you specific tricks to apply this technique, keep in mind that optimization techniques must be performed on the source side, in most cases by writing a T-SQL statement, or within Power Query Editor. Of course, if you're writing custom T-SQL code to import the data to your Power BI data model, keep in mind that you should perform all necessary transformations in your T-SQL logic as the query folding would be broken if you use custom T-SQL query and afterward apply additional transformation steps in Power Query Editor. Okay, for integer columns, you can split them into two even columns using division and modulo operations. In our case, that will look something like this. So basically, we are splitting column with high cardinality to two columns. One of them has lower cardinality, so instead of cardinality of 10, we have cardinality of 1. This one has also cardinality of 10, but with less bits per row, so significant savings on huge amounts of data. Similar technique can bring significant savings when you have decimal values in the column. You can just simply split values before and after the decimal point. In our case, that should look something like this. And finally, similar thing, using similar technique, you can split date-time columns to date and time separately. So let me show you this. And you can see that instead of having 10 distinct values, we have less distinct values, and for time portion, as the maximum cardinality can be 86,400, which is the total number of seconds within the 24 hours. So by using this technique, you can reduce the cardinality of the columns of date time data type, and in case that you don't need to go to a second level precision, you can completely discard this time portion here. Of course, keep in mind that these techniques would require additional effort in the report itself and rewriting your measures to return correct results, so be careful when to use them. I'll go back now to my Power BI desktop file, and since we don't have any decimal values, let's focus on our exact problem, which is optimizing the date TM start UTC column. There are multiple valid options to optimize this column. The first is to check if your users really need granularity higher than day level. In other words, can we remove hours, minutes and seconds from our data? Believe me, 95% of cases, if not even more, day level of granularity will be completely fine for all your reporting solutions. However, I talked to my users and it appeared that day level grain was not fine enough for them, and my users needed to analyze figures on hour level. Okay, so we can at least get rid of minutes and seconds, and that would also decrease the cardinality of the column. So what I did, I imported values rounded per hour, writing my SQL query to retrieve the data. Here it is. I'll show you now in SQL Server Management Studio because it's more obvious what we are doing here. So basically, instead of keeping a whole portion of hours, minutes and seconds, I've rounded all chats to a starting hour. So all chats that started between 3:00:00 and 3:59:59 will be displayed as 3:00:00, so starting hour of this chat. Now if I open DAX Studio from here and let's check data model size after this adjustment that we just applied, and I will go to advanced and view metrics, and if we go to summary tab, you will see that now my data model size is 221 megabytes. So 221 megabytes, it's like 15% so from where we started. But here one thing still bothered me, and this chat ID column, which takes almost 1/3 of my table. And this is just a surrogate key. This column has cardinality that matches the number of rows of the table, which is quite logical, as I said, as it is a unique identifier of my original table. However, this column is not used in any of the relationships within my data model. Just to be clear, and I don't want you to come into some quick and incorrect conclusions, we can't simply remove all ID columns. Some of them, such as IP address ID or customer ID, are used as foreign keys to our dimension tables, and therefore they're part of the relationships in our data model. But chat ID column is just a surrogate key and is not being used in any relationship or calculation. Therefore, I've asked myself if there would be any benefit if I keep the chat ID column at all, since it's not being used anywhere in our data model. Let's go and remove it from the model and see where we are. So I'll go back to my Power BI desktop, transform data, and let's go and move our chat ID column from here, remove, hit close and apply, and let's wait a few seconds for Power BI to apply these changes. You see that the final result, the total number of rows, has not been violated by applying all of those changes. And if I now take a look at metrics of my data model and go to summary, I can see the total size of my data model is in 160 megabytes. That's astonishing. So I didn't lie to you when I said that I managed to reduce my data model size by 90%. If you compare our starting point, which was 1.86 gigabytes, with the current 160 megabytes, I'll let you do the math. One last step to do is to disable auto-date time in options for data loading. If you're not aware, when you leave auto-date time option checked, it will create a hidden date table for every single date field in your data model. So if you have multiple date fields in a table of hundreds of millions or even billion rows, your data model will be bloated with those hidden date tables. Even worse, these tables will search for the minimum and maximum date value in your column and create date range between minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, which is not the rare case, your automatically created date table will span until that date, even if you don't have any record in your fact table that matches that date. And here is another very handy use case of DAX Studio. You can't see these hidden tables anywhere in Power BI desktop, but once you connect to your data model with DAX Studio, you can see them here on the left hand side. So I'll go to options and settings, options, and I will turn off under data load, I will turn off this auto date time, confirm this, and once I check again in DAX Studio, you can see that those tables disappeared from there, and check view metrics, we saved additional 4 megabytes. To conclude, I've managed to reduce my data model size by almost 90%, applying some very simple techniques which enable the Vertipack storage engine to perform more optimal compression of the data, or by simply removing unnecessary columns. And as I said, this was a real use case which I faced during the last year. Maybe some of you now think, wait, Nicola, why did you waste our time with all this blah blah talk about Vertipack and cardinality, etc. What you just shown us is basically just removal of unnecessary columns, nothing special. And you are not completely but almost completely right. In 95% of cases, when you are performing data model size optimization, simple removal of unnecessary and unused columns will be completely enough to get your job done. And as I already mentioned, but it's never enough repeating this, that should always be your starting point when dealing with data model size optimization. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction, using some of those techniques that I've shown you previously with splitting columns and things like that. To conclude, here is the list of general rules, or let's call them best practices you should keep in mind when trying to reduce the data model size. Keep only those columns your users need in the report, and just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our example, sticking with this one rule helped us to make astonishing savings. Try to optimize column cardinality whenever possible. The golden rule here is test, 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 and if you notice a significant benefit from, for example, splitting one column into two or substituting decimal column with two whole number columns, then do it. But also keep in mind that your measures need to be rewritten to handle those structural changes in order to get expected results. So if your table is not so big, or if you have to rewrite, I don't know, hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario and you should carefully evaluate which solution makes more sense. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from the last 10 years, but only 5. That will also reduce your data model size. Talk to your users, ask them what they really need before blindly put everything inside your data model. Aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things we are trying to achieve. If you don't need hours, minutes or seconds level of granularity, simply don't import them. Aggregations in Power BI and generally in tabular model are a very important and wide topic which is out of the scope of this video, but there are some really awesome resources on the web and I strongly recommend reading a blog series on creative aggregations from Phil Seamark on DAX.tips. Avoid using calculated columns whenever possible, since they are not being optimally compressed. Instead, if you need to do some calculations, try to push all of them to a data source like SQL database, for example, or perform them using the Power Query editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date-time data type for your columns. In those circumstances, plain date data type will be completely fine. And finally, disable auto datetime option for data loading. This will remove a bunch of automatically created date tables in the background. That's all, folks. If you enjoyed this video, please click on that like button down below. Even better, you can subscribe to Data Mozart channel and enjoy more cool Power BI and data videos.